Hi, I'm an old guy and I do maths. And today you're looking at something a little different. This is an information sheet that I've made up for a pupil of mine who's learning tangents, sines and cosines, basic trigonometry. And what I've tried to do here is set out the idea of opposite and adjacent and the ways in which you find lengths or angles using a tangent. And so this is probably a video with two purposes. One, to show you the sort of information sheets that I make up, and two, for those of you who are getting to grips with tangents, it's a walk through the rules around them. So let's get started. We have two triangles here, and the idea of opposite and adjacent in a right-angled triangle depends upon the position of the angle that we're concerned with. So in this right-angled triangle, the angle that we're concerned with is down here. This side is the adjacent. It is the side that touches the angle but is not the hypotenuse. The opposite side is here. It does not touch this angle. If we move over to this one, we see that the angle is up the top here. It's got a different orientation. But the adjacent side is still the side that is next to this angle, but not the hypotenuse. So when the angle moves, these move. This side here becomes the opposite because it does not touch that angle. That's the first thing. Now, to find an angle or a length, there are some procedures, and we're going to go through those. The first thing we're going to do is we're going to do lengths, and there are a couple of circumstances in which you're looking for a length. One is that the length is the opposite side, and one is that the length is the adjacent side. And there's, for those of you who are interested, there's a little bit of algebra involved in that. I don't go into that here. I go into the setups for a fairly straightforward TI scientific calculator, which is what I've used for this, and is what most of my pupils up to probably the senior years in high school use. Thereafter they go on to more advanced calculators. Okay, so scenario one, we're looking for the length of this side, and it is the opposite side to this angle. We know this side is 5. So the rules tell us that the tangent of this angle, 40 degrees, is equal to that divided by that over that. Now, our setup for keying this into a calculator, when you are looking at this scenario, is tangent 40 degrees, you push the tan button on this. So if I do that, we'll just clear that, tan, and you insert the 40 there. I like to close the brackets, multiplied by 5 in this case, so you can see that, hopefully. So tan 40, close the brackets, multiplied by 5, and push enter. And the answer I get is 4.2 approximately. I've rounded, as you can see. And so that is how you find the length when the length is opposite the angle. Now, when the length that you're looking for is the adjacent side beside the angle, the scenario is that in this case we've got 60 degrees. The tangent of 60 degrees is 7 divided by x. And what we're always trying to do is we're trying to get x on its own. That's what we did over here. We're trying to get x on its own, and it takes a little bit of algebra sometimes. So rather than go into that, because we're just beginning this, and in the case of some of my pupils, they can do this, but they struggle with algebra, I just put on this sheet the basic keying instructions, which are as follows. You take 7 and you divide it by the tangent, in this case, of 60 degrees, and that's the answer you get. Hopefully you can see that. Hopefully that's nice and clear. So x in this case is 4.04, whatever the units of measurement are, and these are all units of length. Okay, so those are the two cases where you're looking for length. Now, on the other side of this, and I usually laminate these and hand them out, we have the scenarios for angles. Now, the first angle that we're looking for is down here in the left-hand corner. The other angle we're looking for is up here in the top corner. The real difference here is the fact that O and A get swapped around. Nothing else peculiar happens. There's no algebra involved as such. So we're looking for the mystery angle. Now, the rules say that the tangent of this angle, which I've marked with a question mark, is equal to 4 divided by 3. Now, keying instructions for that are as follows. So you can set it up like this, and on a Texas Instruments calculator, its second function, tan, and you'll see that a bracket opens, and you merely insert 4 divided by 3. I like to close the brackets, as it gives me a sense that if I have to push some other buttons, I'm not going to make a mistake. Anyway, the tangent of the angle that we're looking for is 4 divided by 3, and note we use tan negative 1, which is the second function. I think on other calculators it might be inverse, but on these it's second function. And there's our answer. It's 53.13 degrees. That's how we get that. Now, moving over to here, the only thing that's different here is that I've moved the angle, and therefore adjacent and opposite are different. Instead of it being 4 divided by 3, it's going to be 3 divided by 4. Same thing again. Second function, tangent, tan. Sorry, I'm old-fashioned. I learned tangent, sine, and cosine. Okay, so tan negative 1, 3 divided by 4, close the brackets, push go, and the answer is 36.869. Well, I rounded that to 36.87, and what you will notice is that this plus this add up to 90 degrees. The rules say that this angle plus this angle in a right angle triangle will equal 90 degrees. So I know I'm onto a winner here. Anyway, that's my sort of standard sort of information sheet. I make these up with variations. I do it individually for a student. I'm going to get this laminated and hand it to a student today, and we'll go through it. The idea of this video was, as I say, twofold: to show you the sort of information sheets that I make up, and the other was to talk those who are interested in learning about how a tangent works through the process, both for finding a length and for finding an angle. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.